Now I'll talk about the second problem. It is the x random variable x is uniform in -1 to 1. So the PDF of x should always be a half, 0.5 from -1 to 1. And find gx such that if y equals to gx and fy y equals to e to the power of -1 and multiplied by the step function y. First, we can know that the integration of small fx will have big fx equals to 1 plus x over 2 for x equals to for x in -1 to 1, closed interval on both sides, and we will have big fy y by taking the integration of small fy from minus infinite to y, and it is y minus e to the power of minus y. So the relationship between the accumulative function of x and y is that they are equal because y has a relationship to x, which is y equals to gx, and if the accumulative function they are the same, we will know that by solving these two formula we will get y equals to minus ln and y minus x over 2. So this will just be gx. But since we know that we are talking about the x in the interval from -1 to 1, what about the x which is less than -1 or greater than 1? So we know when x is less than 1, big fy y equals to 0, which means the small fy y should also be 0. So how can the g function turns all the x less than -1 to 0? So it is just a constant 0. But for the x is greater than 1, fxx and equals to 1, so as the big fy y. So according to the integration result, how can we make this function y minus e to the power of minus y equals to 1, which means y should goes to infinite. So gx is equal to infinite when x is greater than 1.